Hi everybody, so this is the lab for week 11 when we learn how to make confidence intervals and compare them across groups. So we're going to begin by going into our week by week, and then as I mentioned we're in week 11, and here we have the lab folder, comparing confidence intervals across groups. And just to briefly look at what it is we're going to be doing. We're continuing learning about confidence intervals. We'll review what we did last time where we made confidence intervals around the mean, where we dichotomized a variable and made a confidence interval around that proportion. And then we're going to compare confidence intervals across groups. That's the new thing that we learned about today and that we're going to be talking about in the lab and practicing with our interpretations. So we need to get into our studio. Let me open another tab. Here we go. Lehman 360. And over here into our apps, and we have our studio, and log in again. Okay. So we've been done with swirl for a while now, unless you had some that you hadn't done and were going back to catch up. So nobody should be in swirl, but we always want to make absolutely sure. And so as usual, I'm going to type by with empty parentheses after it. And again, I am so far out of swirl that it doesn't even recognize the by command. So I'm good, I'm out of swirl. Please make sure that you are as well, and then minimize that console window. I'm going to scroll down to a blank line or so on my notebook, and then I'm going to go back over to the lab, and we have code in step 3 of the step-by-step instructions, and we're going to do everything, and in this case it's line 2 all the way down to line 97. Okay. And we're going to paste it. I'm going to remember I started pasting on line 975. Your line will obviously be different, but just remember so you know where you're going to scroll back up. So I'm looking for 975. Okay. So as usual, we want to run our library chunk first. There are packages in here, in particularly this dplyr one and the LSR one, that if you don't have them, when you run commands for confidence intervals, it won't work. So make sure you run your library chunk. And so once we've got that, don't worry about the warnings. We've got our data loaded, we've got the packages in, and so first we're going to just look at a variable by itself without making any kind of comparisons. We're getting a 95% and a 99% confidence interval for one variable, which is TV hours. So I chunked it. The first command just gives us the mean. Remember, the mean is just a descriptive statistic. It tells us about our sample, and it tells us that within our sample, the mean hours of TV are about 2.97 hours per day. The next two are our confidence intervals. The first 2 lines here are for a 95% confidence interval, and we can see that that is from 2.95 to 3.00 if I'm rounding. And our 99% confidence interval, which is covered in these two lines, is from 2.94 to 3.00. So if we are interpreting them, I'm going to say we are 95% confident that the population mean hours of TV watched per day is between 2.955 and 3.00. We are 99% confident that the population mean hours of TV watched per day is between 2.94 and 3.00. And I'm just going to make a note to myself so I remember. Note that the 2.5% and 97.5% for the 95% CI and the 0.5% and 99.5% for the 99% CI are showing where on the sampling distribution our confidence intervals are beginning and ending. They are not the confidence intervals themselves, right? I don't want anyone to get confused and think that the actual confidence interval of 95% for TV hours is 2.5% to 97.5%. That's just showing where on our normal curve we're cutting off at the beginning, and at the end we're leaving off 5% of the area, and we're saying we're 95% confident that our population mean is within this area right there, 95% of the area under the curve. Okay, so we have our interpretations, and remember, you always want to state your level of confidence that you're talking about a population, what type of statistic it is, whether it's a mean or proportion, specify what the variable is, hours of TV per day, and then give the actual interval. We have another question here, comparing the 95% and 99% confidence intervals. Do you see any differences? So let's look at this. With rounding, it's less easy to see, but if you just look at these numbers, you can see that the 99% confidence interval, which is the one right here, is wider. It starts at 2.93, whereas the 95% one starts at 2.94, and it ends at 3.00, where the 95% one ends at 3.99, and so forth. So we can say the 99% confidence interval is slightly wider than the 95% CI. It covers more area. Okay. Now we are going to work with a proportion. And so to begin, you have to get your variable into dichotomous form, meaning it has zeros and ones as its values, or as it's sometimes shown in RStudio, falses for zeros and trues for ones. We're looking at the variable child, and we're making a variable called no child, which is when somebody has no children. That's what this code is saying. Make a variable called no child that is true or 1 if a person has 0 kids, and false or 0 if a person has 1 or more kids. get the frequency, get the mean, and get confidence intervals. So again, we did this last week, so this should look familiar to you. We have our frequency table that shows that 27.3% of the respondents in the GSS said they had no kids. That corresponds to a mean of 0.273. That's the mean for our dichotomous variable. It's the percentage of people who score a 1 or a true. And then we have our 95 and 99% confidence intervals. And again, just to practice with interpreting them, we always want to start with the we are 95% confident that the population, and in this case we're talking about a proportion of childless adults, is between 0.27 and 0.28 with rounding. We are 99% confident that the population proportion of childless adults is between 0.27 and 0.28. With rounding, these end up looking exactly the same, but similarly to when we were looking at our other variable, you can see that the 99% confidence interval is a little bit wider than 95. Slightly wider than the 95% CI. Now, when I did my interpretation here, I did it as proportions, but you could also say that we're 95% confident that the percentage of childless adults in the population is between 27% and 28%. That is also equally correct. Okay, so next we're going to look at another variable and talk about switching it to become officially dichotomous, valued as 0 and 1. Okay, so we have the variable sex. We're getting the frequency for it, and then we're looking behind the labels at how it's coded in RStudio. So sex, we have female and male. Females are 55.9% of the GSS sample. Males are 44.1. When we run it as numeric without the labels, you can see that males, the ones that make up 44.1%, are coded as 1, and females at 55.9% are coded as 2. In order for us to be able to make proportions, we can't have it coded as 1 and 2. We need to have it changed into an actual dichotomous variable. So notice how R assigns numeric values of 1 for male and 2 for female. Is that okay for our purpose of getting a confidence interval around a proportion? No, the coding is not correct to get a proportion. Explain what needs to be done to get the confidence interval around the proportion of males. Need to recode or else make a new variable where males are coded as 1 and females are coded as 0, right? We need it to be, if we want the proportion of males, we want the males to be coded as 1 and the females to be coded as 0. Okay, I'm going to close this video now and start a second one because we're running out of time on this, and we'll come right back to this spot.